welcome to Understand All. I'm your host, Aslakir Gerleaf. Today, we're embarking on a fascinating journey through time and science to unravel the mysteries of viral evolution. So buckle up and get ready for a mind-bending adventure. Viruses. These tiny entities have been the subject of intense scientific scrutiny for decades. They're not quite alive, but not quite dead either. According to a study published in Nature Microbiology in 2018, viruses outnumber stars in the universe by a factor of 10 to 1. Let that sink in for a moment. But why do viruses matter? Well, apart from their immense impact on human health and ecosystems, they hold the key to understanding the very origins of life itself. Scientists have been playing detective, piecing together clues from various fields to unravel the mystery of where viruses came from. There are 4 main suspects in this viral whodunit: the virus first hypothesis, the escape hypothesis, the reduction hypothesis, and the coevolution hypothesis. Each of these theories has its own set of evidence and counter-arguments, making the case for viral origins a complex and intriguing one. Let's start with the virus first hypothesis. Imagine a primordial soup where the first replicators emerged. The RNA world hypothesis suggests that viruses could be relics of this ancient life, predating even cells themselves. Viroids, tiny infectious RNA molecules, lend support to this idea. They're like bare-bones replicators, stripped down to the essentials. But the question remains, where did the first viruses come from? Next up, we have the escape hypothesis, the idea that viruses were once part of cells but broke free to lead an independent existence. Endogenous retroviruses, which make up about 8% of the human genome, according to a 2001 study in Nature Reviews Genetics, are like genetic fossils, remnants of ancient viral infections that became permanently embedded in our DNA. It's a smoking gun, but it still leaves us with a puzzle. Why would genes escape from cells in the first place? Now let's consider the reduction hypothesis. Could viruses be the ultimate minimalists, shedding genes like excess baggage? Imagine a parasitic cell gradually losing its genetic material, becoming more and more dependent on its host. Giant viruses like mimivirus and pandoravirus, with their massive genomes, blur the line between viruses and cells. But here's the plot twist. How did complex viruses become so simple? Finally, we have the coevolution hypothesis, the idea that viruses and cells have been engaged in an eternal dance, shaping each other's evolution since the dawn of life. The Red Queen hypothesis, named after the character in Lewis Carroll's Through the Looking Glass, who says, "It takes all the running you can do to keep in the same place," encapsulates this idea. Viruses and their hosts are locked in an evolutionary arms race, constantly honing each other's skills. It's a story of partnerships and betrayals, with viral genes making their way into host genomes and vice versa. So, where does the evidence lead us? The truth is, the jury's still out. Each hypothesis has its strengths and weaknesses, and new discoveries continue to reshape our understanding. Science is an ongoing detective story, and there's always more to uncover. Take, for example, the vast uncharted territory of the virosphere. A 2016 study published in Nature Microbiology estimates that there are over 1 trillion viral species on Earth, most of which remain unknown to science. This viral dark matter holds untold secrets and surprises. But with cutting-edge tools like metagenomics and ancient virus hunting, we're starting to shed light on this hidden world. But why should we care about the origins of viruses? Well, apart from the sheer intellectual curiosity, understanding viral evolution has profound practical implications. From designing better antiviral drugs to harnessing viruses for biotechnology, the more we know about these tiny entities, the better equipped we are to deal with them. Viruses have also been major drivers of evolution, shaping the genomes of their hosts and even contributing to the emergence of new species. It's a reminder that even the smallest players can have an outsized impact on the grand stage of life. As we look to the future, the study of viruses is opening up exciting new frontiers. Phage therapy, which uses viruses to treat bacterial infections, is showing promise as an alternative to antibiotics. CRISPR, the revolutionary gene editing tool, has its origins in bacterial immune systems that evolved to defend against viruses. Who knows what other secrets and surprises viruses have in store for us? So, there you have it. A whirlwind tour through the fascinating world of viral evolution. We've explored ancient replicators and modern marvels, delved into the mysteries of the virosphere, and pondered the profound implications of these tiny entities. Viruses may be small, but their impact is immense. As we continue to unravel their secrets, We may just find the keys to unlocking the very origins of life itself. And that's a wrap for today's episode of Understand All. I hope you've enjoyed this deep dive into the captivating world of viruses. Remember, science is an ongoing adventure, and there's always more to discover. So keep asking questions, keep exploring, and keep marveling at the wonders of the natural world. Until next time, this is Aslakir Gareleaf signing off. Stay curious, my friends.